So before you answer it, do you know what level means?
Yeah.
What does it mean?
I don't know the definition, but I know what it means.
What does it mean in your own words, I guess?
Like the kind of... Yeah, I really don't know the definition.
So would you say it's like a horizontal line? Or basically, right? So knowing that, which one of these two would you say is correct? If you could read it and then look at the graphs on A or B. So for example, if we had a pool, like a gigantic pool, for example, like it was around 2 miles, 3 miles big, right? Filled with water. Which one of those two will represent the water? A, right? So will it surprise you to know that most people believe it's B?
No, that's surprising.
Did you know that you probably believe it's B as well?
No,
you don't think so? Do you believe Earth is a ball?
No. No, yes, my bad. Never mind.
So you do believe Earth is a ball.
Yeah.
So did you know that in order for Earth to be a ball, B would have to be the physics of water? So basically, this is the curve calculator. You want to take a quick look? I don't know if you ever heard of basically flat Earth. I don't know if that's something you've heard about. So basically, it basically means that the Earth is not a ball. Oh, thanks. So basically, the Earth's circumference is 24,901 miles. So basically, there is a curvature formula for that. And basically, it has to rate at 8 inches per mile squared. That's what it has to, the water has to curve at. And if we were to do a physical measurement of water to see if it actually does that, we all know that water is level, horizontal, right? So basically, the oceans are not any different than that. Basically, they're basically called sea level. I don't know if you heard of the term sea level. That's how they measure altitude and depth from basically a datum line. That's how you get altitude and depth for the ocean.
I'm a 7th grader, so I've heard of sea level before.
Yeah. So that's how they measure, like when the sea level rises. That just means that the line of the ocean basically rises. So I mean, what do you think about people that don't believe in the globe?
They can believe what they believe.
Right. So what do you think? Is it a little? Do you think it's contradicting to basically know how water behaves, but then believe it does the opposite or something different? You don't think that's something to be concerned about? Have you ever heard of this topic before?
No.
Oh, you haven't, really? You never heard anybody talk about not believing in the Earth being around? But wow. Well, this is a topic that's been on the internet for about 6 years. You want to take a flyer? So it's actually, believe it or not, it's being censored online. So this is the reason why I'm right here, just so I could basically let people know, that.
Is that recording?
Oh, yeah, it's actually recording. But yeah, just sharing information about it, sharing direct links, so people could, look into it. Yeah. You have any questions?
No. Thanks, I guess.
There you go. Would you like to answer the question real fast? So it's basically about level, water level. Do you know what level means? In construction, basically what level means.
Zeroed out?
Basically. So basically like horizontal, a line basically. So let's say if we had a pool, basically like a gigantic pool, for example, like a 2-3 mile long pool, right? And we filled it with water, right? Which one of those two will represent the water inside the pool? A or B?
Water level inside the pool?
So when we fill the pool with water, for example, which one of those two graphs? So which one represents the water level?
ADB, right?
So let's say we had a pool, right? Like for example, the lake, and we filled it up with water, the surface of the water, which one will it represent? A or B, basically? A, right? Yeah. So that's what level means, horizontal line. That's what level, exactly. Yeah. So water level, so that's basically geometry, that's construction basically. So basically the whole point of this is that we all know that water is level. Now, before I move forward, what if we change the scale, for example, made it double the size? Would that change it, or would that still be the same, A? It would still be A no matter what, right? Because that's the physics of water, that's the whole point of it. So the point is now that most people, I'm pretty sure you probably do too, but I'm about to ask you, do you believe Earth is a ball? Yeah, so like the globe Earth and all that, what they teach us in school and all that. So basically that defies physics, basically, because the oceans would just be like a huge lake or a huge pool.
Earth is mostly water.
Yeah, Earth is mostly water. So basically Earth is level, basically. So basically what they teach us in school contradicts basically physical reality, in other words.
So
yeah.
you can
Yeah, everybody knows. I mean, because in construction, you know, engineers, everybody knows that water is the best leveling tool too, for for straight and level, right? You know, so we're out here because this information is actually being censored online for whatever reason, and we're just out here, to just spread awareness about it, because it's pretty simple, it's pretty elementary, to be honest. I ask kids about this, and
it makes you have to think so you can question.
Exactly. Yeah. Here you go. Do you want one? Oh, sure. Yeah, man. You guys could look into it, man. Yeah.
It's awesome, man.
Yeah, man. Yeah, it is. It actually changed my whole worldview. Literally changed my world.
It's such a big topic.
Yeah, it is. You've heard about this before?
Of course.
Yeah. How long ago did you hear about it?
I mean, I've been into conspiracy or
Oh, yeah. Yeah. No, yeah.
for a while.
No, yeah.
I'm 30 something, so I've been doing this.
No, yeah. No, this is the biggest one. I'll tell you that. Put it this way. I was like, before this, I believed basically everything the government said. Like, I didn't question it. I would be like, why would they lie? Like, we created them so that they could help us. So like, it doesn't make any sense to me. But then after finding this out, it's like, whoa, like what else are they lying about?
Propaganda's real.
Exactly. Look at it, your news, every time the news starts, the globe's spinning. Every time every movie starts, Universal, the globe. It only exists in a cartoon, basically, in CGI form, because, yeah.
It's like money. It's the faith you put into it.
Exactly. There you go. Yeah.
Yes, guys.
Yeah, man. You have a good one. The question, I don't know if you understand it or you need me to explain it.
Explain it.
So the physics of water, basically, so water level, for example, like a spirit level, you know what that is? Like a spirit level in construct. So for
Yes.
yeah, leveler. So
Okay,
so basically, if I were to ask you, like, what's your definition of level? What would you say?
Level is flat.
Flat, right? Horizontal, right?
Yes.
Simple terms. So knowing that fact, which one of these two would you say represents a pool? Where is, for example, a body of water, a large body of water?
How body of water sits.
So we were talking about that, but if you're here, we're thinking that we could be wrong.
No, yeah. So basically, A is the correct answer. That's that because B obviously that wouldn't be level.
Yeah.
Right?
Container, pool.
Yeah, the water. Now, what if we were to scale? Because that's a 3 mile representation, for example.
Okay.
What if we were to scale that up to like 30 miles? Do you think it'll still be the same, or it would change, or would be B, or it'd still be A? If we just make it bigger, the pool bigger.
Yeah, no, it would be the
It'd
same.
still be the same.
Yeah.
No matter the scale.
I don't think so.
You don't think so, right? Because that's the physics of water. It just collapses to its lowest point.
I think it would matter.
No.
Yeah, because I don't think water could hump up.
Water can't.
What I mean is, like, the Earth is so big that, like, it eventually curves. It's not.
So basically, that's the point.
Because of gravity.
Right?
So that was the point. So you agreed that it doesn't matter the scale. So I was gonna follow up. Do you believe Earth is a ball?
Okay.
So it's actually about that. So
Earth is mostly water.
so
Yeah.
Earth is mostly water. So you agree that no matter the scale, water, when it's contained, a large body of water, it's always gonna be level. So basically, the oceans are contained by the continents. So like this lake, the shoreline is higher level than the water to keep it in, like a bowl,
Yeah,
like a
exactly.
you keep your water in your bowl.
Yes.
So the continents are kind of like a bowl for the oceans, kind of, because they're higher in elevation, so that keeps the water from overflowing the countries, right? So basically, I'm out here basically to show people that we all know that water is level and straight, and we use it in construction every day, engineering. But for some reason, because of our schooling and how, in this time and age, how we were brought up, we believe Earth is a ball because, we were told that.
They don't take in fact like any measurements for the curvature. Everything they do is level.
Yeah.
That's true.
There's long
So I'm,
bridges,
like,
railroad
I'm
tracks.
wondering what the limit is then, like, to where
Where it starts
like,
curve.
So that's the thing. It doesn't. That's the point. So Earth is not a ball. That's the point. It's actually level. Earth is a level plane. So
the Earth is flat.
basically, but that's just it's just flat basically. But I mean, there is mountains and valleys, high points and low points.
Level,
So-
how far it goes and all that stuff, I mean, we don't know. I don't know if you guys ever heard of the Antarctic Treaty. You're actually not allowed to explore independently beyond certain points. There's actually a whole treaty about it. They'll stop you, detain you. You're not allowed to travel without a
Because
guidance.
there are aliens.
I wouldn't know about that, but
Yeah. So
to the topic though.
yeah. So basically, this is like the number one experiment. Basically, that would basically. So basically, this is like, for example, do you know what a plumb line is?
Yeah.
What is a plumb line? Vertical, right?
Yeah.
So 90 degrees from a plumb will be horizontal, right?
Yes.
That's 90 degrees. That's a right angle, right? So if we start from a plumb line and we just build 90 degrees from that plumb line, could we just safely say that that structure will be horizontal? If we kept it 90 degrees from the start, which is a plumb, we just build it straight 90 degrees from the start, right? That'll basically make like a giant straight ruler, right? Now, if we were to build that over a body of water like a lake, a huge lake that's miles in across, and you know, from point A to point B, there should be curvature measurable. There should be water deviating from the structure, showing that the water is curving, right? So if it starts at 5 feet, the gap at us. So basically, the Earth is supposedly curving at 8 inches per mile squared, based on the numbers they gave us. Yeah, so the Earth is supposedly 24,901 miles. That's the equator. So that's like the largest the Earth is in circumference, right? So it's supposed to curve at 8 inches per mile squared based on that number. So at 1 mile, there should be 8 inches in deviation. So what I'm saying in the structure, at 1 mile, there should be an 8-inch difference from the start. But there isn't, exactly. And then the farther you go, the more exponential that curve gets, because it's not a slope, it's a curve.
Depending on the Earth's curvature,
it should be inches per mile squared, but it's not, you know, because, yeah. So basically, we were lied to, you know, growing up and our schooling.
I work for NASA, so I do.
Do you want to?
I work for NASA, so, or I worked for NASA. So.
Oh, you really did?
Yeah.
Oh, really? What did you do there? If you don't mind me asking.
I did all the construction in there, but I ran around with all the scientists and all.
Really.
Yeah. We were working on a mission to Mars.
Right.
I did the Mars yard there.
I see. Okay. So basically.
So I see things that's a little bit different.
Right. So.
Yeah, but everything is, you know, like.
Yeah. You have a question?
But.
Okay. So you're telling me that the Earth is flat, but when you go outside the Earth, it looks like a big circle.
So here's the thing: outer space, what's up in the sky and the stars and all of that. I actually have pictures here if you want to take a quick look at them.
Yeah.
Of the stars. I don't know if you heard of the camera, the P900. It has like an 83 times zoom. No. So these are the stars close up.
You actually zoom in.
So if you,
Look at the stars.
Yeah. So it looks like a light in water, like twinkling.
Okay.
And these are the planets.
Yeah, these are the planets.
So they're very similar to the stars. And this is what they actually look like.
And then these are what when you take a zoom camera and actually zoom.
This is what they actually look.
But
This is Jupiter.
being that they're supposed to be billions of miles away, we shouldn't even be able to zoom into them.
Yeah, so basically they're very similar to the stars, and I don't know if you knew, but back in the day, these were called wandering stars. The planets were actually called wandering.
Yeah.
And the reason why is because they actually have their own unique path in the sky.
Yes.
Because all the other stars are fixed. There's no parallax or nothing, which will be impossible if we're on a globe spinning around the sun and around the Milky Way, while the Earth is spinning on its own too. There should be some kind of parallax in the stars, especially if we're traveling, you know, billions of miles an hour with our Milky Way, you know, through the galaxy, supposedly. But our stars reset every year the same way, no parallax. It's basically like a map, you know, on top of us.
Exactly.
So yeah, so basically that's what the stars are. I think the stars, to be honest, are either reflecting or are on the ceiling. I think there's a ceiling above us. I don't know exactly what that would be, but you know, some people call it a dome, you know, some people that are biblical. I'm not biblical at all, you know, actually was atheist before this. But so this actually brought me to the fact that the Earth is created, but all religions are wrong, basically. Earth was created. Earth was created, but all religions were basically created to keep us from that wonder of like what you know, keep us wondering here and keep us, you know, interested in what this place really actually is. So I think that's the whole point of, yeah.
So what do you think?
I mean, this could possibly be to make us, you know, feel like we're completely insignificant.
Basically,
it's the opposite.
it's the opposite.
This makes
This
us
is
think
all
we're
that
an
exists.
accident. This is just the Big Bang, right?
Yeah, the Big Bang theory.
Yeah.
We're never meant to be here. Therefore, how could we be created if it was
Yeah.
an accident and stuff?
So it's like a light show for us up there, if anything.
Oh,
That's it, you know.
Yeah,
but other than that we could travel there, no, I don't think it's physically possible. And here's another thing that anybody can understand. So when you want to create like a high pressure like environment, for example, like, you know, if you want to create high pressure, how do you do that? You need a container. Would you agree or disagree? Yeah, without a container, or even if that container has a little hole, you can never create pressure on that because the air is always going to be leaking. So the pressure is always going to be decreasing, you know, depending on how big the hole is, right? But my point is that they claim that Earth has pressure. We have 14.7 psi here, supposedly, and outer space is a vacuum, which is the negative, you know, pressure, right? So they try to tell us that Earth somehow has pressure without a container. And that's impossible, physically impossible. Because everything that has, well,
Us as humans.
unless
Yeah.
you believe in fairy tales, because they can't demonstrate it. Can you demonstrate? Do you think? Try to imagine somebody trying to demonstrate pressure without a container. That's like magic. Trying to compress the air without a container,
Yeah.
it doesn't exist. But people believe it because people believe Earth is a ball. You know, it's just a bunch of beliefs kind of like crammed together so that you actually believe. So like evolution, all these they're all theories,
It's all theories.
but they're all theories that back each other up. Because if you just have one theory, people are not going to believe it. It's like, that doesn't make any sense. So they throw in other theories so that you could kind of put the puzzle together and be like, oh, well, all the experts, you know, are saying these theories, and then these experts are saying these theories. So then it must be true then, you know, because all these theories kind of like are intertwined.
Yeah.
You know what I'm saying?
Yeah.
So yeah, it's
It's a
just,
trip.
you know, yeah,
It's a trip.
it is. Trust me, I found out about this 6 years ago, and my life has changed ever since. You know, these are actually photographs taken from 20 miles up. And look at that. This is basically higher than airplanes fly. So airplanes fly at about around 5 miles in the sky. This is 4 times that height without a fisheye lens, because
Weather balloon.
let me show you this. There's a fisheye lens that people like to use as a proof of like curvature, but when you use a GoPro lens corrector, it's actually level. So whenever you see a curvature like this, it's usually a GoPro, you know, because when the GoPro moves up and down, you'll see it concave and convex.
I think it would be really hard to see that dippage. I think it's less. I personally think it's less than the 8
Inches per mile square?
Yeah, oh yeah. Definitely.
Well, that's basically the number.
Definitely. I mean, yeah.
Yeah, that's
I know
what the
where they
official-
get that number from, because
You want to know where they get it? You know Aristophanes? You ever heard of the experiment of sticking a stone, sticking a stick in the floor, 2 sticks in the ground, and measuring the shadows?
Yeah.
So basically, that experiment, it was supposedly done 2,000. I don't believe it, but this is supposedly done 2,000 years ago by this Greek mathematician. And what he did supposedly was put 2 sticks on the ground, and he already assumed the Earth was a globe. So a lot of people think he proved the globe, but what he was doing, he was measuring the circumference of the Earth, already assuming it was a globe. So he was measuring the length of the shadows according to the sun, assuming that the light's coming in parallel. So they were just measuring the shadows, and then he hypothetically came up with a number. So
Yeah.
that's the number that we use. That's the number NASA uses. You should double check. You should double check.
Because,
Yeah, these are NASA numbers. I don't.
Yeah, at 8 inches.
8 inches per mile squared. Oh, check it out. Look, this will be the exact formula, and this is to scale, I believe. There we go. Check it out. That's the exact formula. And I actually created my own using the Pythagorean theorem, which is actually accurate for the first 300 miles, and you could check that one out too. Yeah, it should be in here. There you go. This is another formula, and they're accurate for the first 300 miles. And again, even if you make the Earth double that size, there has to be curvature at the first 3 miles. Yeah, go for it. Yeah. So there's no getting, even if Earth was 1 million miles in circumference, there should still be measurable curvature within 5 miles, even if it's a couple feet, you know? There should be. It can't be level, you know, and say it's
'cause
curving.
We just did a water line that was
Exactly.
Oh shit! I'm sorry.
It's okay. It's okay.
We just did a water line, a 12-foot diameter water line.
Okay, there we go. Yeah.
And that we couldn't even tell that there was curvature on it. We couldn't tell.
Exactly,
And
yeah.
that's only 12 feet. We
Okay.
couldn't tell.
Yeah.
We were on top of it.
Yeah.
And we're like, dude, this thing is
It's
not
like a
right.
mirror.
Yeah.
Even
And
lakes
so
that are.
we're thinking, and so once we dug out to sides more, we're like,
Right.
oh shit, it's starting to drop. And so
Well, because
You know what I mean?
well, that was the level
So
going
that-
down because
yeah,
you're making the container bigger, so the water level is naturally
No,
going to
no.
decrease.
It was like this. It's like this.
Okay.
It's like this. And if it was 12 feet in diameter, and we're standing on top of it, we're looking
Okay.
for it.
Okay.
We couldn't tell that there was a curve on it, and that's only 12 feet. Imagine a mile. And so once we started digging, then we're like, okay, now it's starting to drop on that side, it's starting to drop on this side. So if I'm thinking that a mile and 8 inches in a mile,
right.
to me, it
Right.
just doesn't make
So-
sense.
so-
it'll be a lot.
Exactly level. There's
What's
a lot
that?
of the ground isn't exactly level. There's
No.
a lot of deviations, hills.
So you're talking about you couldn't see.
Yeah,
it looked flat,
Yeah,
right?
well, once we put a string line on it, then we could see it, but it was very minimal.
Okay.
Compared to.
Okay, but your point is that you think the curve is there, but you just can't see it,
Yeah,
right?
we're-
Okay.
I don't think.
So
I think it's a lot less than
Okay.
8 inches, but I do think that there is a curve.
So you think that if we were to actually do, so you don't think water would be level then? You think water is,
Yeah,
so you think water
yeah.
does this, but
No,
just
no, no.
less.
But see, the thing is the Earth has mass gravity.
Right.
Mass gravity on it
Right.
that
Gravity
holds
is-
everything in.
So, for example,
You know what I mean?
so let's say we were, so let's say we were like a lake that was 20 miles across, right? A lake, like in, somewhere in Michigan or whatever. So you think that water does this, but less? You still think water does that, but less on that lake? That's miles across. Because we should be able to measure even if it's less, because again, we could physically build a structure that we know is level. Again, we'll go from plumb and construct horizontal from over a lake. That lake should deviate from the structure, but I guarantee you it's going to be level. It's going to be parallel to the structure we built, because water is not going to curve. I guarantee that. But again, if you're saying that you think it does, then you must believe that it does what B does, but less,
Yeah, it'd be very minute.
Yeah,
it'd be
but
very, very minute.
yeah, I think this is a. Do you think there's a better experiment or a more accurate experiment than this one to measure if water does deviate, or do you think this one will be a pretty good one to replicate? I guess.
No, that's great.
Yeah, there's
I
actually.
think it's great-
Yeah,
great
there was
analogy.
actually a fundraiser about it. It was called the Force the Line experiment. People were talking about this years ago already. And it was a mathematician on YouTube, actually. He actually graduated. I don't know if he had a master's or not, but his brain was Brian Mullen. I don't know if you could look him up. But he's the one that kind of like talked about this. One of the first ones to talk about creating. He called it the Force the Line experiment, and basically doing the same thing. Oh, thank you. Yeah, I gotta close it. So basically, he was talking about forcing the line, basically creating a perfectly horizontal structure that we can, and he said, and obviously we could do it with lasers, cutting perfectly 90-degree angles, in every section, to make sure that every block or every, whatever we use, it's perfectly straight to the next one and to the next, 45 degrees. So basically, he said, we only need about 2 miles, to be able to see if there's any deviation. So he was basically, his job was threatened, basically. So either
That's what trips me out is there's so much secret stuff that once you, like you were saying, you go past a certain limit, they stop you. I mean, there was stuff that at work that it was nuts. Stuff that I've seen.
It's pretty wild.
And so I mean, I don't know what's out there.
No,
It's crazy, man.
Did you know though? Since you work for NASA, just real quick, did you know that they don't have any real photographs, right?
I beg to differ.
They actually, I made on their website that they're not real photographs; they're images. Yeah, you could look this up on your time.
I don't know.
Yeah, you guys can look this up on the website. I'm not making it up. This is what they say. So
I don't know. I mimic. I'm one of the only guys to mimic Mars.
Yeah. So the reason why is because of legality. If they did claim they were photographs, they could get sued basically if somebody were to take them to court. So they have to call them images legally, and they admit it openly. This is not a secret. You could go on their website. So. But yeah, man, this is
right on.
Basically, yeah.
I don't know.
Yeah.
Food for thought. It's up on like YouTube and everything. Everything's right.
Yeah, it's kind of, but then again, you see this on Google, you see that online, but when you get there,
right.
You know what I mean?
Yeah.
I was there. So,
Yeah.
So it's.
Well, again, they like to keep everything carbon correct.
I mean, so.
Yeah, and then I'm pretty sure.
They might be able to say like that they aren't actual like pictures of them. They just tell everyone else that they are.
Well, they are because they actually have. There's been a lot of like people looking. We'll actually have two different ones here. Like, so you can see the inconsistencies. One from 2002 and one from 2012. So if you want to hold that one. So this one's from 2002 and this one's 2012. And this is the same diameter. Can you see the differences in those?
Yeah.
Right? Look at the size of America. Covers almost 1/4 of the globe right here. And right here is tiny. So it's just basically just to show how inconsistent. But they're both Photoshop. They admit them. They're not photographs. That's the point.
I don't know. There's. I've been there, so it's kind of hard to.
No. Yeah, I understand that. Yeah. It's a hard, it's not an easy topic.
Yeah. No, but you know what, dude? It's good to be open about it. Like,
No, yeah. To be honest, there's a lot of people that are closed, and I just, to be honest, I feel sorry for those people that are closed-minded like that.
I've been there.
Yeah.
I've seen a lot.
Yeah.
And
I could guarantee you though that people are above you. Do you know what NDAs are? You know what NDA? Non-disclosure agreement. You know what that is?
Okay, I mean, it makes sense.
Basically, if someone, it's basically a contract saying that you won't speak on the topic.
Of course.
Yeah, a lot of people are
The
military. Did you know NASA is part of the military?
Yeah.
Yeah. So basically, a lot of people, especially astronauts, they sign NDAs. So they're
Oh yeah.
they're on.
Of course.
I
had to sign one when I worked there.
There you go.
Yeah.
So who's to say that maybe
I didn't
some?
know it was an NDA though. I never heard that.
I see.
that term.
No, yeah. So who's to say that maybe some people above you, maybe that actually maybe do know, sign NDAs and they can never speak to the people on the lower levels. Maybe
And,
where
and that's very true.
So
Very true.
that's
But some of the stuff that I've seen with my eyes, it's hard to fight with that. Because I actually seen.
Yeah.
It,
You probably didn't see curvature though. Maybe not through a screen.
Yeah. So what's that?
Have you seen curvature? You seen like of
I never really paid attention, to be honest
No?
with you. No, I never really paid attention.
Yeah, next time you go to the beach, take a look at it, and you know,
Yeah, no, I mean, yeah.
it's pretty horizontal.
That we've seen.
Yeah. So,
Yeah. No, yeah, man.
yeah. So, all right, man.
All
Hey,
right.
thanks.
No
thanks
problem,
a
man.
bunch.
Yeah,
Thanks a
take
bunch.
care, man.
All right.
No problem.
Have a great day.
Yeah.
Have a good day.
Yeah, you too.
Bye, thank
Have a good
you.
one. No problem.
Bye, bye, bye.